Hello children, welcome to My Dream. Today we are talking about the gravitation. Yes. Gravitation ले रहे हैं पहले. Gravitation. Today we are talking about the gravitation, in which we are discussing the Kepler's laws. First of all, we are talking about this is the sun. So Kepler first law, all the planets revolves around the sun in an elliptical orbit. All the planets revolves around the sun. Kirchhoff first law, Kepler's first law. All the planets revolves around the sun in and around the sun in an elliptical orbit. जितने भी प्लैनेट हैं वो सन के चारों तरफ इलिप्टिकल ऑर्बिट में मूव करते हैं. So Kepler's first law is also known as law of orbit. Kepler's second law, that is law of area. Area swept by the planet must be equal in equal interval of time. The area swept by the planet, swept by the planet must be equal in equal interval of time. This is aphelion, this is perihelion. The distance of the closest approach to the sun, that is perihelion. This is aphelion. Now, from P to Q, this is R to S, in equal interval of time, the area swept by the planet from R to S and P to Q will remain same. Next, Kepler's third law, that is also known as law of periods. The square of the time period is directly proportional to the cube of the semi-major axis. The square of the time period is directly proportional to the cube of the semi-major axis. This is square of time period directly proportional to this. As you replace the proportion sign, there is a need of a constant. If you are comparing, then it can be written down. Or you can say T2 is equal to R2 by R1 raised to power 3 by 2 into 2. For the comparison point of view, you can go through this. Now we are talking about this is the planet, this one is the sun, position vector R, mass of the sun, mass of the planet. Then according to the gravitational force is directly proportional to the product of their masses. If it is multiplied by a unit vector, there is no effect. And you know unit vector is equals to position vector divided by this. So in place of this, you can write down GMSMP, R position vector. You can make the negative sign. Here negative sign indicates the gravitational force is meant for attraction only, not for the repulsion. Whereas when we are talking about the electrostatic force and the magnetic forces, these forces are interactive in nature, attraction or repulsion both. So torque, as the planet revolves around the sun, then you can write down the torque experienced by a planet, tau is equals to R cross F. This is R, this is minus GMSMP R cube into, it can be written down GMSMP R cube R cross R. And you know R cross R, position vector R cross R, that is equal to 0. So torque is equal to, which is a constant. If no external torque is applied, then the angular momentum is conserved. Tau is equals to delta L by delta T. As as tau 0. So L is constant. Yes. Now we are talking about the aerial velocity. Suppose yes, planet revolves with the aerial velocity v, then the area that is half r into delta. In place of delta r, you can write down v delta t. Delta A by delta T gives R into V. If it is multiplied by the mass and divided by the mass, then the aerial velocity is given by L upon L is equal to R cross MP. This is the aerial velocity remain constant. As angular momentum is a constant, so their aerial velocity will become constant. Now we are talking about the derivation of Kepler's third law. The gravitational force is given by capital G M S and P. Minus sign तो ये indicate करता ही है it is for attraction, and as it revolves like this, the centripetal force works mv So in place of this, you can write down G ms by r v square, and t is equal to 2 pi r by v, or in place of r v, in place of v you can write down r omega, या तो इसमें रखो वैल्यू या ऐसे करो. This is G M S upon R cube omega 2 pi by t. So square of the time period is directly proportional is R cube, which shows square of the time period is directly proportional to this, because ये तो constant है बेटा. Kepler's third law, aerial velocity. If no external torque is applied, then angular momentum is conserved. Now we are talking about the gravitational force. What do you mean by the gravitational force? Gravitational force of attraction between the two objects is defined as it is directly proportional to the product of their mass and inversely proportional to the square of the distance. Yes. So gravitational force is given by, that is m1, m2 as you can write down like this. If you are considering the Earth is supposed to be spherical and the object of mass is small m, then it can be written down like this. Gmm upon r square. Negative sign indicate कर रहा है, it is meant for attraction. Now, relation between small g and capital. As the diagram is given to you, the gravitational force is given by this. And F is equals to mg. क्योंकि ऑब्जेक्ट पर टेस्ट मास कौन सा? टेस्ट मास तो ये कौन सा मास है? ऑब्जर्वेटिव मास. And small m into g, that is gm by r square. So small g, gm by r square on the surface of Earth. On the surface of Earth or a planet you can consider. So this is the formula of the gravity on the surface of Earth. G is equal to gm by r. If r tends to infinity, then g will become 0. Gravity, in terms of gravity, in terms of mean density, gravity in terms of mean density. Earth is supposed to be spherical. So density is equals to mass oblique volume. So mass is equals to V rho, and it is supposed to be concentrated as sphere. So that is the mass, volume of the sphere is given by 4 by 3 pi s cube. Here you can put the value. Small g is equals to gm by r square. It can be gm four by three pi r cube into rho. Then you will get g is equal to 4 by 3 pi r cube pi g r rho. For the comparison point of view, G1 is to G2, R1 rho 1, R2 rho. Now, for the इसको ऐसे भी लिख सकते हैं जी पी इक्वल टू जी एम पी अपॉन आर पी, gravity on the surface of Earth, G M E upon Then you can write down GP, gravity on the another planet, that is MP by ME, and this is RE upon R. For the comparison point of view, you can go through this. Okay. Now, effect of height, on the gravity. This is the Earth, is supposed to be spherical, and you want to discuss the gravity at this certain height. As you see, gravity on the surface of Earth, is given by small g is equal to gm by r square, which shows gravity is independent to the mass of an object. It depends upon the observative mass, not the test mass. Gravity at the height h, above the surface of G H GM by distance कितना है, that is R plus. Gravity at the height h, that is gm by r plus h whole square. So g h upon g, gm by r plus h whole square, gm by r square, which can be written down r plus h So GH by G can be written down this upon this. साफ पता चल रहा है ग्रेविटी सर्टेन हाइट पर बेटे कम हो गई. Either we are moving away from the center of Earth or toward the center of Earth. In both the cases, gravity goes on decreasing. Yes, for long distance. For short, you can write down 1 minus 2h upon by using binomial expression. By using binomial expression, आप क्या करेंगे, डिग्री ऑफ ऑर्डर 2 को ऊपर ले जाएंगे और उसको एक्सप्लेन कर. यस, GH by G, GH by G, one plus H by R. Now, at what height above the surface of Earth. surface of Earth. The gravity is reduced to half. One-fourth to that of the surface of Earth. At what height above the surface of Earth the gravity is reduced to? One-fourth, half. So given है आपको बेटा GH is equals to G by 2. So GH upon G, which is equal to 1 by 2, and you know the value of GH by G, that is equal to 1 plus H by R whole square. Take the square root. So H upon R is equal to root 2 minus 1, which is 0.414, and the radius of Earth, you know, 6400 kilometers. Then you can write down 2649.6 kilometers. One-fourth वाला अपने आप कर लेना बेटे, ठीक है? कोई डाउट है? अरे कोई डाउट है बेटे? At what height above the surface of Earth, the gravity is reduced to 36, reduced by 36 to that of the surface, When we are talking about reduced to and reduced by, reduced to बेटे एज इट इज ले लेते हैं, 36 या 36, रिड्यूस बाय में क्या करें, 100 में से सब्ट्रैक्ट कर लेंगे. सो GH by G, first 36% of G. of G. So GH by G, that is 36 by 100, and which is equal to 1 plus H by R whole square. Take the square root. 1 plus H by R. 6 plus 6H by R. 10, 6H by R is equal to 4, and H is equal to 2 by 3 R. And now you can put the value. Yes. When we are talking about the reduced by, then you can subtract from 100. So here you will get 64%. The next. Effect of depth. On the gravity. This is supposed to be Earth, and we want to discuss the gravity at this depth. This is the Gravity on the surface of gravity on the surface of Earth is given by gm by r square or 4 by 3 pi capital G r into rho. So here you can write down gravity on the surface of Earth is given by this. Gravity at the depth d. Gravity at the depth d. Gravity at the depth d is given by GD 4 by 3 pi capital. अब कितना डिस्टेंस बचा? r माइनस d. Then GD upon G r minus d upon r, which can be written 1 minus d by r. So GD upon G 1 minus d. Again you see 1 में से सब्ट्रैक्ट हो रहा है तो ग्रेविटी डिक्रीज कर रही है. If नया क्वेश्चन ले लेते हैं. If GH is equals to GD, gravity at the head for short distance, मतलब H ज्यादा बड़ा नहीं. Then 1 minus 2H upon R, 1 minus D upon R, 1 minus 2H upon R, 1 minus D upon D. D is equals to twice of H. Next, gravitational potential energy. Potential of the system. So F is equals to आपने पढ़ा minus du by dr. So delta W is equal to F minus dr. And gravitational force is given by Gm small m by r square. And you are taking the limit from infinity to r. या तो आप यहाँ से इन्फिनिटी भेज दें या इन्फिनिटी से यहाँ लिया. Here we are taking the limit this. Gmm by r raised to power minus 2 dr, limit infinity to r. Then you will get minus Gmm 1 upon r, r raised to power minus 1 divided by minus 1, and which is given by Gmm by 1 upon r minus 1 upon infinity, upper limit minus. So you will get Gmm by r. If you want to discuss some numerical which is based on it, you just make a system. Say M1, M2, M3, equilateral triangle. Equilateral triangle is given to you. And you want to know the gravitational potential. This is A, B, C. Gravitational potential energy with this, and with this. This is minus G M1, M2 upon A. M2, M3, M1. If the masses are same, then you can minus, if m1 is equals to m2, let it be m3, which is m, then you can have minus 3 gm square by. Yes. Now we are talking about the gravitational potential. Gravitational potential. The amount of work required to bring a unit mass substance from infinity to a particular point, that gives the gravitational potential. आपने पढ़ा होगा V is equals to W upon Q naught, इलेक्ट्रोस्टैटिक. यहाँ पढ़ेंगे M naught. The amount of work required to bring a unit mass substance, and this is M naught. This is the gravitational potential energy is given by GMM by R. This is the test mass. So it can be written down GMM by R. Yes. Now, we are talking about, इसको भी आप डिस्कस करना चाहें तो कर सकते हैं. Calculate the gravitational potential. At the centroid of an equilateral triangle. यहाँ पता करना, ग्रेविटेशन पोटेंशियल में एक ही होता है कि दो मास नहीं होते. ये a/2 हो गया जी, और ये हो गया 30, तो ये कितना हो गया O A B C. Here OA is equal to OB, which is equal to OC. This is base upon hypo, so cos 30 is equals to a/2 upon OB. So OB हो गया cos 30, that is under root 3/2, which is equal to a/2. Now OA is equal to OB, that is equal to a/√3. इसकी वजह से कितना पोटेंशियल होगा, और इसकी वजह से कितना होगा, और इसकी वजह से कितना होगा. ठीक है. सो V across AB, V across BC, V across CA. Potential at O due to A, यहाँ पता कर रहे हैं. V C GM by a√3, GM by A, that is minus 3√3 GM by A. This is the gravitational potential at the center of an equilateral triangle having the same mass. Now, escape velocity. The minimum velocity required to throw an object the minimum velocity required to throw an object that will not return back to their gravitational field. So, according to conservation of energy, that is change in kinetic energy, ऐसे लिखो, this is minus, यहाँ से फेंक रहे हैं, कहाँ फेंक रहे हैं, यहाँ ये escape कर गई, ये भी, ये object ये रहा, and this is half mv square, this is GMM upon R. This is the escape value. So that is the minimum velocity required to throw an object. V is equal to 2gm बड़ा वाला, और ये हो गया ये. दिस आप जब इनकी वैल्यू रखोगे तो 11.2 किलोमीटर पर सेकेंड आ जाएगा. अगर आपको लिखना एज वी नो v is equal to gm by r square. So in place of gm you can write down gr square. यहाँ से लिख दीजिए, that is twice of gr square r 2gr. वैल्यू रख दीजिए, अगेन you will get the 11.2 किलोमीटर पर सेकेंड. Yes, next. Orbital velocity. Orbital velocity. Orbital velocity में आप दो बातें इसमें भी लिख सकते थे, r प्लस h सर्टेन हाइट से ऊपर से फेंक रहे हैं, या तो आप यहाँ लें सरफेस पे, यहाँ से 2, 4, 20, 25 किलोमीटर से कोई फर्क नहीं पड़ता. और आपको अगर यहाँ लेना है तो सर्टेन हाइट आपको लेनी पड़ेगी. ये डिपेंड करता है आप कहाँ ले रहे हैं. आप यहाँ घुमा रहे हैं या नियर द सरफेस ऑफ अर्थ घुमा रहे हैं. देन as this object of mass small m revolves around the planet or earth, then there is a centripetal force. Centripetal force भी लगेगी, gravitational तो लगी रही है. Yes, they are anti-parallel to each other. So mv naught square by r, v naught the velocity. So mv naught gm m by r square and v naught is equal to gm by r. This is the orbital velocity. As we know, g is equals to gm by r square. So in place of gm you can write down gr square. Here in place of gm you can write down gr square divided by r. Then we will get simply gr. That is about 8 kilometers. Yes, there is the gravitational force, there is the centripetal force. Now, relation between the sk velocity is given by 2gm by r, and orbital velocity is given by gm by r. So VE upon VO, that is equal to root 2 VE, that is V, not root 2. If it is multiplied by this, I bataya, then you will get 11.2 kilometer per second. After that, we are talking about the weightlessness, at which, as you know, gravity at the center of Earth will become zero. बताया था आपको. Gravity at the depth d, that is given by this. If d is equals to r, then gd is equal to gc, center, then 1 minus r by r, which is equal to 0. That time weightlessness shows. Now, this is all about the introduction of gravitation. In the next session, we will discuss the problem based on gravitation. Okay.